How's everyone doing? Well, this is basically the last physics class because there's just no class on Friday, Denise has decided, so please enjoy that day. Instead, today we are going to go over all the information that I feel you will need for the exam. As a reminder, the exams for this course take place Monday, April 29th. There are two times listed on the lower left of the sideboard there, 8:30 and 1:30 on that day. I don't care which one you show up for if you have a preference and your schedule allows for it. Just know that probably a lot of people are going to choose to show up for the 1:31. But you may attend either. And, well, first of all, questions, feelings, concerns, etc. before we continue today. All right. Well, since it's the last class, I would like to congratulate everyone. You've made it. You've conquered physics, and there's only one obstacle left. And frankly, that one obstacle is stuff you've already done before, because the exam is basically just test 1 and test 2 again. You've already accomplished that, so it's smooth sailing from here, right? I believe in you guys. You've all done very well. I have your averages to prove it. Now, there we go. In prepping for the exam, I have posted a final exam tab. Within the tab, as with the previous two tests, there is a list of all the concepts from the previous chapters that will be on the exam. This is basically the test 1 list and the test 2 list with a few differences. I have removed a few small things that we only covered briefly and that just didn't make the exam. And I have added the electricity stuff for Monday and from lab this week. Now, we only covered that very briefly, so I'm only planning a very small number of questions on the exam about it, mostly concept driven. What is there, I have summarized here. First up, I want you to note the difference between volts, amps, and ohms. Volts is appropriately the measure of voltage, which drives electricity. Amps is the measure of current, that is the electricity itself. The amount of amps is the amount of electricity. And ohms is the measure of electrical resistance. If something's resistance has low ohms, it is a good conductor. If something's resistance has high ohms, it is an insulator, and current doesn't want to flow through it. So I want you to at least remember that concept. I find those good vocab words to know. Secondly, I want you to know the primary difference, what I consider the primary difference, between series and parallel circuits. Now, if you haven't had lab yet this week, that's okay. If these vocab words don't mean anything to you yet, lab this week is meant to go over it, and this information is in the notes if you've looked at those. I want to briefly mention it though, just so that you've heard it from me outside of lab. Basically, there's two main ways of building a circuit, those being series and parallel. This really just refers to the order in which you connect everything up to the battery. In a series circuit, you just create one straight path, one loop, where everything is just wired in directly one after the other. Wire light bulb, followed by wire light bulb, followed by wire light bulb. That is a series circuit because everything is connected in series, sequentially. The other pattern is a parallel circuit, where the different light bulbs are kind of separated into separate rungs. Basically, the current hits a fork in the road and splits, literally like a road fork or a fork in a river. And some of the current's going to split and go through this light bulb, some of it's going to split and go through this one, some of it's going to split and go through this one. These are the two main orientations that circuits can be constructed in. And the difference between the two that I want you to remember is that a series circuit will die if anything is disconnected. That's because in series, there's only one path to travel down. And if that one path stops functioning, the circuit stops functioning. To compare this to Christmas lights, if you had a string of Christmas lights that's turned on, and one light bulb dies, if those bulbs are wired in series, the whole string goes out. Because there's only one path that is now disconnected. Current can't flow through a dead light bulb. Literally, the filament, if it's broken inside the bulb, current can't get across it, and therefore it doesn't work anymore. So series light bulbs, series Christmas lights, immediately die if one bulb goes out. Hence, at least classically speaking, the frustration of having to check every single bulb on your string to make sure that they work. Now, most Christmas lights aren't wired like that anymore, thank goodness. Most modern Christmas lights are wired in parallel. Dang it. My projector's apparently in series, because if anything disconnects, the whole thing stops working. If something is wired in parallel, that kind of future-proofs it in case one element of the circuit dies. Bless you. Think of the different rungs of a parallel circuit as being multiple bridges that the electricity can go down. And if you have more than one bridge, you have more than one option in case one of the bridges goes out. If one of these bulbs dies or I just remove it, that one path is no longer an option, but the other two paths remain open. And so the one bulb dying, the others still stay on if they're wired in parallel. And this is how most modern Christmas lights are built, thank goodness. The only thing I really want you to remember about these is that series, one bulb goes out, the whole thing dies. Parallel, one bulb goes out, the others stay on. That's the extent of the vocab words you need to use in the exam. Does that sound good? All right. This is in the notes, the same notes that I presented. So if you've been using those are the last 3 slides in that set of notes. They are also on Brightspace. My projector going, or did I do something silly? Okay, that one's on me. So, this study list is basically just the test 1 and test 2 list. Couple things taken out, electricity tacked on at the end. I've had one student ask me to try to determine how many exam questions each concept is tied to, and to put a number for each on here. I'm working on that. I've just been trying to figure out the best way to present that information. So if this sheet changes, if I add numbers to it, that's what those we're going to try to represent.
How many questions will be total?
The total exam is 17 questions. Note that most of those would be multi-parters to some extent. But each single part wouldn't be very long. I haven't counted, I guess, the number of parts, but it's 17 questions, similar to how on most of my tests. Most questions are multi-parters. They'll ask you different facets of the same scenario. And the exam is formatted like my tests. It's printed up the same way, it's just longer, basically. And each question will tell you how many points it is worth, so that you know how long you might want to spend on it. Does that answer your question? Okay. Cool. Of the 17 questions on the exam, there is 210 points spread between all of them, graded out of 200 points, which really just means that the highest score is still 105. It's just more points because there's more questions. That's all. And to study for the exam, I have posted another practice test. Again, the way that I make my practice questions is I always write the test or exam itself, and then I write this to make sure that the questions on it are representative of what's on the actual assignment. So, if there's nothing else you do to study, I'd recommend this. I'd recommend doing more than this to just study, but if you do only one thing, let it be this. If it's not on that concept list and it's not used on here in some way, it's not on the exam. Note that I always make these longer and more difficult because I'd rather you make the mistakes here where I'm going to give you a key for it. So there's 24 questions on this of varying length as opposed to the 17 on the actual exam. I'll point out again, because this was on test 1, but that was a while ago. Practice test asks you to write Newton's laws of motion. The actual exam will ask you to pick them out of a lineup. 5 statements, number which ones are laws 1, 2, and 3. 2 of them are not laws of motion at all. Sound familiar? Okay. So, very good study aid. I'll be posting an answer key for it either this afternoon or Friday afternoon. I will also be posting the answer keys to test 1 and test 2, because I do recommend using those as study material, since the exam is basically just those again, but just those again, basically. So I'll be posting answer keys for those. The only thing I'm waiting on is one student who's been out needs to make up the second test before I post that. But I'll post the answer keys. You're encouraged to use your old tests as study material. If you have not collected your copy of either test 1 or test 2, please let me know and you may have it and keep it. Yes?
You can still bring our formula sheets on.
Yes, you are encouraged to bring your formula sheet. The test is kind of written assuming you have one. I will, as always, have copies of the formula sheet for you to use during the exam. Speaking of the formula sheet, before the exam I will be editing the version that is on Brightspace, because I've noticed there's a couple things missing from it. So I will be changing the document that's on here, but I will also be separately posting just a page that has everything that was missing on it. So if you don't want to, like if you've been working on a copy and have all your modifications to it already written, you can just print out the extra page that has the missing formulas. Alternatively, if you don't have one of your own, you can print out the fully edited copy. And the fully edited copy will be what I have a stack of at the front of the room on exam day. Does that sound good? All right. And that is basically everything I think you need to know for the exam. Everything on it is definitely stuff you've seen before. So nothing new. I don't want to throw curveballs at you at the last second. And during the exam, I will be here in the room. I encourage you to ask questions, and I encourage you, as usual, to leave nothing blank, because that's the only way to get 0 points. And I think you guys are going to do great. I have been watching you learn and grow, and I even have your numeric averages to prove how much you have learned. And so I think you guys are going to do great, and I think you're going to get it done and then move on to a wonderful summer. I'm proud of all of you. Any questions for right now? Okay. As you are studying over the next little while, do please let me know any questions you have. Either email me or come find me. We may not have class on Friday, but I will still be in the building on Friday. With all that said, there is one last thing that we need to do while we're here together in the room. Who remembers this thing from the start of the semester? This was the 30 multiple question, very short, not graded for accuracy assessment we did at the start of the term, so the department could know what starting physics students know before they started physics. Now that you've taken physics, we're going to do it again so the department can see what you learned, and so that we can use that to continue making the program even better. And I will give you a free lab grade for doing it. It's not graded for accuracy. You get lab points for doing it at all. Sound fair? This will take up the last 30 minutes of this lecture. Once I hand these out, you guys can get started. You don't need a calculator or a formula sheet. It's still just concept multiple choice. And once you're done, you can hand it in to me and then be on your merry way. Any questions or objections? All right. Come around the room with this stack and also some Scantrons. I ask that you put all answers, as a bubble on the Scantron. You can write on the packet, but you do not need to. You also do not have to necessarily write your name and student ID on the front because this is not the information that the computer gets. So you don't actually need to know what your student ID is. I know I certainly didn't as a student. Whoops. No, pencil only. For some reason, computers just don't read pen. Note again, you do not have to write your student ID on the actual packet. I do ask, though, that somewhere on the Scantron, you write your name, your year at the school, and your section number for this course. Your year would be freshman, sophomore, etc. Your section number would be Physics 1000 F, followed by X, W, or Z, depending on which day of the week you are supposed to attend lab. V being Monday, X being Wednesday.
But we can show that any sessions.
You can, yes. But for the sake of the department's data, we just ask for the thing to be written on the Scantron.
How do you know what section we are?
This, if you are scheduled for this lecture, you are in F section.
Okay.
And if you are scheduled for, say, Monday lab, you add a V onto the F. If you attend Tuesday lab, you add a W onto the F. And if you attend Wednesday lab, you add an X onto the F. Again, just put those somewhere on the Scantron. It doesn't technically matter which box they go to. And once you're done with this, hand it on back to me, and then please continue to have a wonderful day. Thank you all for being my students.